Myself, Emba Anuprasad, working as assistant professor in Department of Mechanical Engineering in the MBR College of Engineering and Technology. Today we will discuss about cast iron. So it is the overall second unit, Amma. It is the first second unit. It is the first topic of the second unit. So what is the iron and different types of irons? Next one is what is the defined steel and types of steels one. And next one is non-ferrous metals one. So in total we can study about metals. Metals in two types. One is ferrous metal, second one is non-ferrous metal. These two topics we will learn about in this second unit one. So comes to today our first topic is iron. So comes to the iron one. So out of the all metals, the iron is the most popular metal. So overall all metals, the iron is the most popular metal. Why? Because in the mostly applications we can use it for iron. So and as the being in construction activities since prehistoric times one. So construction field one machine ship you can use it for iron one. Without iron the construction cannot made. So machine ship the material need the mostly the iron metal is need for constructions. It is one of the point one. So iron is the chemical element. It's the symbol of Fe. Iron is the one of the chemical element. The symbol is Fe, and the atomic number is 26. And the atomic number is 26 one. So it is available in abundance and estimated that is constitutes about 4.60% is the crust of the earth. In earth, the iron is available in 4.60 percentage. Overall, the material, the iron material is available percentage is in the earth 4.60 percentage one. In Latin one, the iron is known as ferrum. In Latin, the iron we can call as ferrum one. So the chemical designation is a common one, but there is chemical designation is no changes, but name is different for in Latin language. In Latin language, we can call as ferrum one. The material are grouped in two categories. Generally metals are grouped in two categories: metals, non-metals, metalloids one. So in metals generally we have two types: one is ferrous metal, second one is non-ferrous metal. So in ferrous metal, the ferrous metal contains iron. The ferrous metal contain irons, so that why we can call as it is a ferrous metal. There are mainly three important ferrous metal. There are three important ferrous metal. There are first one is cast iron one, second one is rough iron one, third one is steel one. These are the three important ferrous material in ferrous materials. So second one is see here, non-ferrous material. Non-ferrous material do not contain iron one, so that's why we can call as it is a non-ferrous material one. So mainly examples are aluminum, copper, extra. So these are the non-ferrous materials examples one. So ferrous metal means nothing but the ferrous metal contain iron one. So that's why we can call as the ferrous metal. What are the ferrous materials means? First one is cast iron, rough iron, and steel. So non-ferrous iron without contain iron one. So that's we can call as non-ferrous metal. And examples are aluminum, copper one. Next one comes to the cast iron. So it is a previous, it is the cast, it is the iron one. Comes to it is iron introduction one. So it is a cast iron introduction one. So in cast iron is the name given to the those ferrous material containing more than 1.7 percentage carbon one. Sorry, it is one not 1.71. It is a 2 percentage. So in iron equilibrium diagram, the carbon contain 2 to 6.61 percentage is called as the cast iron one. So it is similar in composition. Similar in composition one, it is a cracked pig iron as produced by the blast furnaces one. So it is iron used in bolt and nuts one. So cast iron used in doors. So generally it is applications of the cast iron one. So the structure is crystalline and relatively weak in tensile tension one. So the structure is crystalline structure. We can see on cast iron the structure is crystalline structure, but the relatively it is a very brittle material. The properties are very low. So one of the lowest property material is brittleness one. Next one is weakness in the tensile tungsten. So next one is composition of the cast iron. The composition for cast irons, in cast iron we can use the different types of materials. So what are the different types of elements means? Sorry, the number of elements we can use it in cast iron. What are the elements in? First one is carbon. carbon we can use 2.5 to 3.7 percentage. In cast iron, we can use the carbon content is 2.5 to 3.7 percentage. Silicon 1.0 to 3.0 percentage. Manganese 0.5 to 1.0 percentage. Phosphorus 0.1 to 0.9 percentage. Sulfur 0.07 to 0.1 percentage we can use in cast iron. These are the composition of cast iron. Composition is nothing but without we can use the composition, the metal is a pure iron. Pure iron. In our previous class we can discuss about phase diagram, iron carbon equilibrium diagram. In iron equilibrium phase diagram one, the pure iron is melt on 1539 degrees onwards. So remaining are alloys only. Alloys is nothing but, so we are using in one metal we are using in so in two elements must instead one is a metal one. So the combination of any two metals which is at least one metal is known as the alloy one. So that's why we are using in this metal one we are using the elements. So what are the elements means? These are the elements. So see here, carbon, silicon, manganese, ferrous, sulfur. So these are the different types of elements composition we are using in cast iron one. So that's why it is also one of the alloy. Cast iron also one of the alloy. So see here, properties of cast iron. So what are the properties of cast iron means? It is a stronger in compression but weak in tension. So it is a strong in compression one but weak in tension one. That is the first point one. Comes to the second point, that tensile and compressive strength of cast iron are average quality. The tension and compressive strength of the cast iron is average quality. The quality is very low, or not average quality, not very low, average quality one. The average quality is how much means 150 Newton per mm square and 600 Newton per mm square respectively one. So it does not rust easily one. It does not rust. Rust form is not easily one. It placed in salt water, it becoming soft one. So మనం ఒక ఐరన్ తీసుకొని కాస్ట్ ఐరన్ తీసుకొని ఒక we can place it in salt water one. So after then we can see it become more soft one. So that is one of the main important one. So low melting point one. So why? Because we can use it in cast iron we are using the alloy one. So that's why the melting point is very low one. So good fidelity. So next one, it is hard but it is brittle also. It is hard and brittle also. So it does not ductile. It does not ductile, hence it cannot be adapted to absorb the shock. So shocks it cannot absorb easily, and shock impacts also it cannot absorb easily one. So its melting temperature is about 1250 degrees centigrade one. The highest melting temperature about the cast iron is 1250 degrees centigrade one. So next thing one, it shrinks on cooling one. It shrinks on cooling one. So these are the properties of cast iron one. So applications of the cast iron. Generally, cast iron we can use it for different applications. One, cast iron is used in wide variety of structural and decorative applications. One, so wide variety of structures we can use it. Why? Because iron is easy to iron are used to make different types of shapes one very easily. Why? Because it is very easy to cast one. So that's why they are designed, they are manufactured different types of parts one. They can manufacture different types of parts one. ఎలా అంటే అమ్మా క్యాస్టర్ అనేది అంటే క్యాస్ట్ ఐరన్ యూజ్ చేసుకొని మన పార్ట్స్ మ్యానుఫ్యాక్చరింగ్ చేయడం అనేది చాలా ఈజీ. వై? బికాస్ ఇట్ ఈస్ ఎ వెరీ యూజ్డ్ casting material. So that's why they are manufacturing daily. They are manufacturing for new types of production, new type of material they are producing one. So that is one of the example one. So see here. So because it is a relatively inexpensive, durable one, easily cast into a variety of shapes one. So it is inexpensive one, durable one, and easily cast into variety of shapes itself. That is the point one. So construction of machines and structures, construction of machines and structures also, structures, this type of structures also we can use it. So as column blasters and arches. So column blasters it is arches. Columns also we can use material is cast iron one. So machines and car parts. So it is the machines. So and car parts also we can use it for cast iron one. Blocks, cylinder heads, gearbox, cases, cookware, pipes. These are the applications of the cast iron. These parts are made material is cast iron one. So these are the one of the applications of the cast iron one. So next one, see another example one, stove on fire bricks. So stove on fire bricks also one of the example, one of the application for the cast iron one. Vehicle engine. So this vehicle engine also it is made for cast iron. So generally we have the two wheelers, four wheelers. So two wheelers, four wheelers, we can see the engine. The engine part is made for cast iron material only. So that is the one of the application ones. Next one is used for decorative purpose, good fidelity and elasticity also. So see here this gate design also, these gates also we can use it for cast iron material. Design made for column, this column also we use it for cast iron material one. So decorative patterns, so see here number of patterns we can see, these are the, we can use it for gates. So you can use it for different purpose, you can use it in this different types of parts one. So these parts are made for cast iron only. So these are the one of the applications. See here another applications, so it is we use it for bridges. So it is a first bridge, iron bridge. So it is manufactured in first iron bridge, it is made for England. The country is in England, in England country the first iron bridge they are made in. So it is the first arch bridge in the world to be made of the cast iron, a material which was previously too expensive to use it for large structure one. So it is the first iron bridge, cast iron bridge made in England. So next one is the crack repair in bridges. The cracks also repaired in bridges one. Crack supports. So these are the also these one also used for cast iron one. So these are the different types of applications in cast iron one. So buildings. So see here another examples of the cast iron. By using the cast iron, we can made for different types of parts. One, see here it is a columns. Columns also made for cast iron material. Rough trusses also. So next one is a long span roof. It is a long span roof also made for cast iron one. So see here, so these are elevations, different types of elevations. So these are also used for cast iron. So these are the examples of the example, not for example applications of the cast iron. So the next one, see here what are the disadvantages of the cast iron. Why design terms of the cast iron. So cast iron disadvantage, first one is weight. So weight is the first one. When the weight is more one, often what happens, the brittleness is more in cast iron. So when we have the more weight one, automatically in this weight one we can see one of the disadvantages is brittleness. So brittleness in cast iron, that is the second disadvantage. First one is cast iron weight. Weight is the first disadvantage of the cast iron. Second one is brittleness. So it is a brittleness one, easy to break. So next one is resistance towards the heat one. So resistance towards the heat, when we can heat the cast iron one, automatically the properties will change suddenly one. Some example, you can take the any one iron one, go to the heat treatment process, go and heat in that material one, automatically inside the properties will change suddenly one. That is also one of the disadvantages of the cast iron one. So these are the disadvantages. Next one, see here, cannot overcome from the environmental causes. So one of the disadvantages are very important disadvantages are cannot overcome from environmental causes. Some example, one environmental causes is nothing but, so we can see rust formation one and cracks. These are the general environmental causes one. So we cannot overcome this one. And sudden shocks. So sudden shocks also we cannot do anything one. So these are the one of the disadvantages one. So next one comes to the next topic, types of cast iron. Generally cast iron are four types one. The first one is white cast iron, gray cast iron, malleable cast iron, ductile or nodular cast iron. So generally we have the cast iron, but the cast iron we can use it for some applications only. But we are cast iron we are using more one. So that's why they are divided. The category four types of cast iron one. The first one is white cast iron, gray cast iron, malleable cast iron, ductile or nodular cast iron one. So first one we can see white cast iron. These are iron carbon alloys having more than 2.11 percentage of carbon one. So these are iron carbon alloy having more than 2.11 percentage of carbon one. In white cast iron, the carbon content we can use it for 2.11. So more the minimum carbon content we are using 2.1, maximum is 6.67 percentage carbon content we are using in cast irons. So in white cast iron, the carbon content we are using 2.11 percentage only. So it is a microstructure of cast iron. See here why we can call it as it is white cast iron means all the carbon is present in the combined semi-type form one. all the carbon is present in the combined cementite form one. So that's why, which makes the fracture of these alloys to have the dull and white color. So the all carbon present in the combined cementite form one, which makes the fracture of these alloys to have the dull and white color. So it is the dull and white color one. So that's why, that's reason, so their name as white cast iron. So that's why we can call as it is one of the white cast iron. So that these alloys to have the dull and white color. So it is we have dull and white color. So that's why we can call as it is a white cast iron. What are the compositions we are used for white cast iron? Means, see here, these are the compositions we are using in white cast iron. So white cast iron is one of the metal. So these are the elements. These are the element used in white cast iron. Different types of elements we are used in white cast iron. So it is the white cast iron. So properties of white cast iron, see here, hardened wear resistance is one of the properties of white cast iron is it has the high hardness and wear resistance we have. So the hardness and brittleness increases, automatically the carbon content increases. So when carbon content increases, automatically the hardness brittleness also increases in white cast iron. So some example one, the carbon content we are using 2.11 percentage here, but we can increase 2.60. Automatically what happen in this material one, the properties will be changed suddenly. What are the properties will be changed means, the hardness and brittleness also increased. When the carbon content increases, automatically the hardness and brittleness also increased in white cast iron one. So the hardness Brinell is what are, how much hardness and Brinell means 375 to 600 we can see hardness one. Next one is strength, tensile strength we can see on 20,000 to 70,000 watts. Next one is compressive strength we can see on 2 lakhs to 2 lakhs 50,000 watts. So this is a compression strength one. So it is a tensile strength one. This is a hardness Brinell strength one. So when the carbon content increases, automatically hardness brittleness also increase one. The hardened we have the high hardness and wear resistance also. These are the properties of white cast iron one. Limitations, because of extreme brittleness and lack of machinability, white irons find limited engineering applications somehow. So engineering applications, what they are finding means, so it is a extremely brittleness and lack of machinability one. So these are the one of the limitations for the white cast iron. So next one is the applications of white cast iron. See here, it is used to make malleable iron. It is used to make malleable iron, white cast iron, to increase ductility and mal 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 be lies one. So often we can go for malleable cast iron one. So see here, so linear for a cement mixer. The cement mixer are made for white cast iron. Ball mills, this is made it is made for white white cast iron material one. So certain types of drawing dies also we are made for white cast iron material. So extrusion nozzles, all these type of nozzles are made material is white cast iron. So these are the applications. The next one is gray cast iron. Gray cast iron. Iron carbon alloy containing flakes of graphite. So iron carbon alloy containing flakes of graphite embedded in a steel matrix one. So the carbon total iron carbon containing a number of flakes one. So flakes of graphites embedding in steel matrix one. Steel matrix will be formed in this gray cast iron one, which is slow as a gray blackish colored fracture due to graphite one. So we can see in this diagram one. So blackish colored fracture due to graphite one. This one. So the free form of carbon are called as gray cast iron. The free form of the carbon. This is a free form of carbon we can see on this diagram one. So that's why we can call as it is a gray cast iron. This is a gray cast iron one. Iron carbon alloy containing the flakes of graphite embedded in steel matrix one. So carbon alloy ఏం చేస్తుందంటే కంటైనింగ్ చేస్తుందంటే flakes of graphite embedded in steel matrix one. So which slow shows a gray blackish colored fracture due to graphite one. So the free of form of carbon are called as gray cast iron one. The strength of gray iron depends on the strength of the steel matrix. The strength of the gray iron is depending on the strength of the steel matrix. So the strength will be depending on the matrix one. So and the size and character of the graphite flakes in it one. So it is one of the point one. So a typical features of gray cast iron is a graphite in the form of flakes in the microstructure one. So you can see number of flakes in the gray cast iron one. This is a structure of microstructure one. This is the structure of gray cast iron. This is the microstructure. So each and every iron we have the one of the individual microstructure. So it is a gray cast iron microstructure we can see here. So next one is compositions. What are the compositions we can use it in gray cast iron? Means see here, total carbon content we can use 2.4 to 3.81. Silicon we can use it for 1.2 3.5 percentage one. Manganese we can use 0.5 to 1.0 percentage one. Sulfur we can use 0.06 to 0.12 percentage one. Phosphorus we can use it 0.1 to 0.9 percentage one. We can use it in compositions in gray cast iron. Next one is what are the applications of gray cast iron? Means internal combustion engine. So these are the internal combustion engines. This is the what applications one. So pump housing one. This is a pump housing one. Wall bodies one. Wall bodies also one of the one of the applications of the gray cast iron one. So electrical boxes. So next one is electrical boxes also one of the example one. Castings. Decorrect to castings. Next one is cast iron cookware, disc brakes. These are the applications of the gray cast iron. Gray cast iron. By using the gray cast iron material, we can made this type of parts one. First one is cookware, disc brake, decorrect pattern one, pump housing one, internal combustion engine one, electrical boxes, wall bodies. So this wall bodies, pump housing. So these are the applications of the gray cast iron. So next one is malleable cast iron. Malleable cast iron. The third one is malleable cast iron. Malleable cast iron is a cast white iron. The structure being is a metal stable carbide in a parallactic matrix one. Parallactic matrix one. So next one, our previous one is graphite matrix one. So here is parallactic matrix form. So graphite is a nodular form one. In this one, in this malleable iron, the graphite is a nodular form one produced by heat treatment of white cast iron one. So this malleable cast iron how can be produced means so by heating the white cast iron. After then we can produce so malleable cast iron one. So produced by heat treatment of white cast iron one. So graphite nodulars are irregular clusters one. So simple properties of ductile iron. So we have the simple properties for the ductile iron one. So see here components. What are the components we can use it for malleable cast iron are so carbon, silicon, manganese, phosphorus, sulfur. So these are the components we are using in malleable cast iron. So these are the microstructure of malleable cast iron. So these are one of the example one. It is one of the applications of the malleable cast iron one. So see here. So these are the components in malleable iron. It is one of the iron one. In iron one, the carbon content we can use this percentage silicon, manganese, phosphorus, sulfur. All these are we are mixing one. After then we can go for heat treatment process one. After then heat treatment process, what happen? All these materials are solid becoming liquid one. The liquid one we are powering to the pattern one. We are making the we can, after then we are cooling the liquid metal. Automatically we can get the final object. So this one we can call as the this one we can call the preparation of the materials in castings. So next one we can see applications. Malleable iron is better for thinner casting. Thinner casting purpose you can it is the most suitable one. Vehicle components. So vehicle components are best example one. So why? Because good machinability one. Power trains, power trains, frames, suspensions, and wheels. So these are wheels. So these are the application steering components. So steering components see here, transmission and different parts, connecting rods. So connecting rods also it is made for malleable cast iron one. So next one is the railway components. Railway components also we are used for malleable cast iron one. So next one is pipe fitting one. So pipe fitting also we can use it for gray cast iron. It is a railway tracks. So this material is gray cast iron one. So malleable cast iron. Sorry, I'm a malleable iron, malleable cast iron one. So these are the These are the applications. So these are the applications of malleable cast iron one. So next one is fourth one is nodular one. So see here, these are the malleable cast iron structure applications. These are structures and applications. So next one is ductile nodular cast iron. So it is the fourth one is ductile or nodular cast iron. So in this ductile iron, the graphite is in the form of spherical nodules rather than the flakes one. So the graphite structure we can see on spheroidal nodular rather than the flakes one. So these are flakes, number of flakes we can see on this structure one, thus beating the creation of the cracks and providing the enhanced ductility. So and providing the enhancement of ductility. So that's why we can call as it is also one of the nodular and ductile cast iron one, also known as the spheroidal graphite, and also we can call as nodal graphite iron one. These are the compositions. The typical chemical analysis of these materials are iron. Carbon is 3.3 to 3.4 percentage one, silicon 2.2 2.8 percentage one, manganese 0.1 to 0.5 percentage one, magnesium 0.03 to 0.05 percentage one, phosphorus 0.005 to 0.04 percentage one. So next one is sulfur 0.05 to 0.02 percentage one. So these are the applications. So these are the applications. These are the applications of the nodular cast iron one. So next one is conclusion one. So these are the overall cast iron sum. These are today class sum. Thank you, Amma.